Basic radiation safety. What is industrial radiography? Industrial radiography is a non-destructive testing method to check for defects, for example, cracks, lack of penetration, porosity, inclusion, pinholes, in pipes to ensure quality durability in the metal products. With radiography, we get information inside the metal just by taking a picture of it without breaking it or spoiling it. The industrial radiography devices are commonly called as cameras. They are either gamma cameras or X-ray cameras. How do the radiography cameras look like? Rowley 2, Delta 880, Techops, typical X-ray camera. The radiographs, images taken by these cameras, a crack in the pipe. Where is radiography carried out? Radiography is usually carried out in rooms with thick concrete walls. It could also be done in the open space, such as during testing on gas oil pipelines in the field is called open field radiography. Radiography is sometimes carried out in areas in shop floor of a factory. Radiography in rooms. Open field radiography. Radiography on the shop floor. What is used in the radiography camera? There are two different types of radiography cameras. One uses the gamma radiation source and another uses X-ray radiation source. Inside the gamma radiography camera, there are small radioactive sources in the form of pellets, typically of the size 0.3 mm x 2.5 mm dia, that gives radiation. This radiation goes through the metal parts and its image is taken. This is just like the X-ray of your chest by the doctor. However, the difference is that the radiation coming from the radiography camera is highly penetrating as compared to the chest X-ray. The gamma radiation source assembly is called as a pigtail. Radiation is emitted continuously from the source even when the camera is not operating. The outer thick shielding of camera protects the people from this radiation when camera is not operating. Picture of a pigtail. What is radiation? Radiation is natural and is everywhere. Radiation sources are in the earth, air, sky and water. The banana you eat also has small amounts of radiation source. Also, the air we breathe and surrounding us, the water, tea, coffee you drink also have very small amounts of radiation sources. Apart from this natural radiation, there are artificial or man-made sources of radiation, man-made sources of ionizing radiation, natural source of ionizing radiation. Is the radiation from mobile phones same as ionizing radiation? No, the radiation from gamma camera is called ionizing radiation and that from mobile phone is non-ionizing. More examples of ionizing and non-ionizing radiation is given below. Sources of non-ionizing radiation: mobile towers, microwave oven, mobile phone, X-ray clinic, gamma camera. X-ray radiography. In general, ionizing radiation is more harmful than non-ionizing radiation. Is radiation harmful? Radiation can neither be seen, heard nor felt. It can be detected only through an instrument called radiation detector or survey meter. So, it is very difficult to understand if you are entering an area where there is more radiation. Radiation exposure is potentially harmful if handled improperly. Therefore, Atomic Energy Regulatory Board, AERB, specifies limits to such exposure as per international norms. Take for example, electricity. Touching a battery of 1.5 V cell is not harmful, but touching a high-tension wire results in burn injuries. How to work safely near radiography camera. The radiography camera is properly packed with thick metal with very minimum radiation leaks. Hence, it is safe to use by properly following instructions. Touching an insulated wire is not harmful, while touching a bare wire can cause injuries. Similarly, using a shielded camera with source properly inside is not dangerous, while being near the source when the source is out is dangerous. Danger with radiography camera. The radiography camera has a small but powerful gamma radiation source in the pigtail. Normally the pigtail never falls from the camera because of its mechanical integrity with device. If by any chance, the pigtail falls due to untoward incident, run away from the place immediately and inform your seniors. They will use special tools to place the pigtail in a safe shielded container. Do not hold the pigtail with hands. It will result in severe burns, sometimes leading to amputation of fingers, hands. A helper had held the pigtail and the result is severe burns. Always remember that radiation cannot be seen, heard, or felt. So you will not come to know if you have been exposed immediately. For such severe burns, there is no effective specific treatment available. 1. Understand the symbols. These symbols mean radiation sources. 2. Understand who takes care of safety. Every institution has a radiation safety officer, RSO. Find out RSO of your institute. Always follow instructions of RSO. 3. Understand safety when gamma camera is used on the shop floor. 1. Identify the cordon-off area. 2. Never enter the cordon-off area and always stay outside. Do not enter radiation area. Stay outside radiation area. 3. Always be alert to the warning lights alarms when the source is out for taking images. 4. Do not come near the camera without instructions from certified radiographer RSO. Industrial radiography on shop floor. 4. Understand TE do's and don'ts. Never operate the camera by yourself. Do not place the camera where it is likely to get stolen or lost. Do not handle the camera without instructions from certified radiographers. Report to RSO if the camera falls from the height, scaffolding, etc. If the pigtail comes out or falls from the camera, keep safe distance, run away from the pigtail and inform your RSO employer. 5. Understand safety principles to avoid unnecessary radiation. Time, distance, and shielding, TDS, are the basic safety principles of radiation safety. Time. Spend less time in the vicinity of camera when radiation is on. If radiation level is 10 microsievert hours, person remains in this field for 1 hour, will receive dose of 10 microsievert, and in 30 minutes, for example, in half time, dose received will be 5 microsievert. Distance. Be away from the camera when radiation is on. If radiation level is 10 microsievert hour at 1 meter, at 2 meters, the radiation level will be 2.5 microsievert hour. For example, double the distance, the radiation level decreases by 4 times. Shielding. Stand behind shielding, for example, thick concrete wall. When radiation is on, radiation level decreases significantly behind dense and thick material. for example, thick concrete wall. 6. Understand dosimeters. If required, the RSO might give you a DRD or TLD. 1. DRD, direct reading dosimeter. 1. Do not drop the DRD. 2. Return DRD to RSO. 3. Do not take the DRD home. Return it to the RSO after the day's work. 4. Do not leave the DRD in the radiation area. 2. TLD, thermoluminescent dosimeter. 1. Do not use somebody else's TLD. 2. TLD should be placed at the chest level. 3. Do not open the TLD. 4. Do not take the TLD home. Return it to the RSO after the day's work. 5. Do not leave the TLD in the radiation area. 1. Does TLD-DRD protect me from radiation? No. TLD-DRD does not protect you from radiation. It only measures the radiation dose you might have received. 2. Does radiation will cause cancer? When we talk of cancer with respect to radiation, we talk only of the risk involved. The risk of cancer on exposure to radiation, within limits, is very small and not distinguishable among other possible causes of cancer. 3. Now that I know about the equipment, can I operate it? No. You cannot. The camera shall be operated only by certified radiographer. 4. Is the X-ray in an X-ray clinic and from radiography camera same? No. The X-ray strength in a clinic is much lower. The X-ray, or gamma ray, from a radiography camera is of much higher strength and can cause severe burns even with seconds of exposures in case of accidental situation.